Last part here deals with the Lewis dot diagrams and the structural formulas. What we're going to do is we're going to make the Lewis dot diagrams, come up with a name for that shape, and determine whether it is polar or not. A couple items to remember is when we have an atom with molecule with carbon, carbon always goes in the middle. If we don't have an atom with carbon, the most electronegative element will go in the middle. So let's start here with the first one. We have a carbon with 2 oxygens. So in the middle we're going to have carbon. And carbon naturally has 4 valence electrons, and oxygen is going to have 6 each. So here's carbon with its 4 valence electrons. And then oxygen each with 6. So the structure of this, the name of this structure is going to be 3-atom linear, and it is non-polar. Good way to remember it, if you were to cut this atom right down the middle, if both sides look exactly the same, it's non-polar. Next one will be arsenic with 3 hydrogens attached to it. So arsenic has 5 valence electrons. And each hydrogen is going to have 1. So if you were to cut this element in half, you'd see that it would not look the same on every single side because there's 2 electrons right here that aren't anywhere else. That's a trigonal pyramidal, and it is polar. So a good way to remember this, if I have electrons left over, not bonded to anything on the central atom, so the way I say it, if electrons are left over, your shape is polar. Excuse me, we have a so the carbon with 3 hydrogens and 1 chlorine. So the carbon would start off with 4 valence electrons. And each hydrogen would each have 1. And then the chlorine would have 7. We call this shape tetrahedral. Basically, it's an atom in the middle with 4 elements on the outside of it. And because not every side of this element looks the same, it's considered to be polar. So again, if you cut this element in half, you can see that this side has more electrons than this side. So because there's more electrons, this one is polar. The next one is a 2 hydrogens, carbon, and an oxygen. So carbon always goes in the middle. We put oxygen on this side, and we're going to put our 2 hydrogens over here, and I'll show you why in just a second. So we're going to have each carbon, so the carbon's going to have 4 valence electrons. I'll come back to that last one in a second. The oxygen is going to have 6, so we're going to put one of them there, 2, 3, 4, 5, and the 6th one would be right here. So between the 2 electrons that we're going to have left over, one's going to be here on the carbon and one's going to be on the oxygen. So because they're going to be left over, not bonded to anything, we're going to take them and we're going to put them in the middle of our compound, forming a double bond. And then again, each hydrogen is going to have 1 electron by itself. So you can kind of see here, it's going to be flat, but it looks similar to a triangle. So we call that trigonal planar. And because, again, you cut this element in half, cut it right down the middle, there's more electrons on this side than there is on this side. That shape would be considered polar. Next one on this page is water. So we don't have an element carbon in this particular compound, so we take our most electronegative element, which is going to be oxygen, and we put it in the middle of our compound. So we're going to put oxygen here with its 6 valence electrons. The hydrogens would then be on the outside, and each one of them would have 1 valence electron. So the central atom has 8 valence electrons, so we cut our element in half, And you see that there's more electrons on this side of the compound than there is on this side of the compound. So that would be polar. And how I remember this is if there's electrons left over, your shape is bent over. So again, because there's electrons here on the side, instead of our element being flat, it's going to be bent like this, making this element polar. All right, last page here, we have a carbon with 4 hydrogens. If you remember, this is called methane. That's one of the 3 compounds that you're going to need to memorize this year. And because we have a carbon, the carbon is going to go in the middle with the 4 hydrogens around the outside. So carbon is going to start off with 4 valence electrons. And the hydrogen is going to bring 1 valence electron each. So now the central atom of carbon has 8 valence electrons. Each hydrogen has 2. This will become a stable compound. This is tetrahedral and is nonpolar because if you cut this element down the middle, you cut it in half, both sides of that compound look exactly the same. So because both sides are the same, that is a nonpolar compound. Moving on here, we have hydrogen, oxygen, and chlorine. Between these 3 atoms, oxygen is going to be the most electronegative element, so it's going to go in the middle. Chlorine here, and hydrogen there. Oxygen is going to have 6 valence electrons. Hydrogen is going to have 1, forming a bond right there. And chlorine is going to have 7 valence electrons. So one of them is going to be transferred to that portion of the oxygen atom, and then it's going to have its 7 others on the outside. This would be a bent, because if you look here, we have electrons left over in the middle atom right here and right here that are not bonded to anything. So because there's electrons left over, your shape is going to be bent. And this atom is also going to be polar because if you cut this element in half, there's more electrons on this side of the line than there is on this side of the line. So, or you can say that both sides of this element do not look the same. There's 2 different elements, that's why it's polar. And we have boron with 3 hydrogens. So boron is going to be in the middle with the 3 hydrogens on the outside. And we're going to space them as far apart from each other as possible. Now boron itself is in column 5. It's only going to have a certain number of valence electrons, and the hydrogen is each going to have 3. I'm sorry, the 3 hydrogens are only going to have 1 valence electron, excuse me. So it's going to look like this. So because the boron is in column 13, it's only going to have 3 valence electrons around the outside of it, forming a compound that looks like this. And if you look at it, it kind of looks like a triangle. And because there's no electrons left over in the middle atom, it is trigonal planar. And because each one of these sides looks exactly the same, it is nonpolar. Next one, we have hydrogen, carbon, and nitrogen. Carbon is always in the middle. Even though nitrogen is more electronegative, carbon, rule number 1, is always in the middle because it has 4 available bonding sites. Nitrogen will put on one side, hydrogen will put on the other. Carbon is going to have 4 valence electrons. I'm only going to draw the first 2. And hydrogen has 1. So there's one of our bonds right there. Now nitrogen has 5 valence electrons. I'm going to draw this just a little bit differently. I'm going to put 2 of hydrogen's valence electrons right there. Now if you remember, nitrogen is going to have 3 electrons that are going to be by itself over here. And carbon is going to have 2 electrons right here. So the first pair of electrons, the nitrogen is going to have 1 here, carbon 1 there. They're going to form a bond. Well, the 2 that are going to be up here, we're going to pair up and we're going to put in the middle. So one of carbon's valence electrons is going to go there, and one of nitrogen is going to be moved from there to there, forming a bond. Then carbon is going to have another lone pair electron right here, and nitrogen is going to have a lone electron right there. We're going to move those to the middle, forming a triple bond. So this is a 3-atom linear, and it is polar. Now the reason it's not bent, if you look at the middle atom, there's no electrons left over on the middle atom, so it's not bent. It's going to be a perfectly flat element. Compound. But if you cut this compound in half, you have more electrons on this side than you do on this side, So that's why it's polar. Or you can say this side of the compound does not look the same as this side, so that must be polar. Our last compound is ammonia, NH3. So between these two elements, nitrogen is the most electronegative, so it's going to go in the middle. And we're going to put our 3 hydrogens around the outside like that. I'm going to tell you why I'm going to put it like that in just a second. Nitrogen has 5 valence electrons. So that's how we draw 5 valence electrons around the outside of an element. Hydrogen each is going to have 1. So they're going to be bonded like so. And as you see, we have 2 valence electrons left over. So remember we talked about earlier, if there's electrons left over, your shape is going to be bent. So it's not going to be trigonal planar like this one was here. It's going to be bent over, so it's going to be trigonal pyramidal. And because if you cut this element in half, I cut it in half there, this side of the compound does not look the same as this side. Or you can say there's more electrons on this side than there is on this side, causing this side to be negative and this side to be positive. So because there's poles of that compound, this compound is polar.